Hello everybody, welcome to the video. Today it's going to be all about circles. We're going to be talking about how to graph these things given the equation. We're going to be talking about sector area, and we're going to be talking about arc length. So first of all, let's talk about what exactly is a circle. So basically, a circle is a collection of all the points that are the same distance to a given center. So all these points, A, B, D, and E, are a distance of r from this center C. So that is pretty much what a circle is. So I want to talk a little bit about some characteristics of a circle and some equations that you might be familiar with. So first of all, a radius is just the distance between the center of a circle and the circle itself. That's the radius. A chord is a segment between 2 points that are on the circle. So this is an example of a chord right here. Here's another example. Here's a third example of a chord. Then we have a diameter, and that's a chord that goes through the center of a circle. So that's going to be your diameter right there. So please note that the diameter is double the size of a radius, right? So in this case, D is equal to 2 times R. You've probably seen the equations for the circumference of a circle, and remember, the circumference means the distance of a circle's edge. So I've kind of highlighted it here in yellow. That's going to be the circumference. So the circumference, the equation is going to be the diameter times pi, or you can think about it as 2 times pi r, since as I said earlier, the diameter is just 2 times the radius. The area is the two-dimensional space inside the circle, and the equation for that is pi r squared. So let's put this into practice. I want you to use these equations right here to calculate the circumference and the area of each circle. So what I'd like you to do is just to pause the video and to go ahead and do that in your notes real quick, and we're going to get started in a few seconds. Okay, everybody, welcome back. So let's start with the circumference. So for this example 1, we know the radius is 3, and the equation for the circumference is 2 pi r. So it's going to be 2 times pi times 3. 2 times 3 gives you 6, so 6 pi is the exact answer. However, oftentimes we write the approximate answer because that's going to be more, you can kind of see more clearly what that number is. So if you do 6 times pi on your calculator, you get the approximate answer, which is 18.8 centimeters. So that's going to be this outer distance right here of this circle. It's about 18.8 centimeters. Okay, now for the area, that's going to be pi r squared, as you can see right here. So that's going to be pi times 3 squared. 3 squared is 9, so the equation for the area is 9 pi, and that's going to be your exact answer. But let's multiply those two to find the approximate answer, and that gives you 28.3 centimeters squared. So that's this whole distance right here. And the reason why centimeters is squared is because we're talking about area. Again, that's a two-dimensional measurement right there. So that's the case for example 1. Okay guys, so let's head up to example 2 right here. Notice that for example 2, you're given the diameter this time, not the radius. So the diameter is 14 centimeters. So in order to find the radius, what we need to do is take that 14 and divide it by 2 in order to get 7. The radius would be 7. Then we can plug in that 7 into the equation for the circumference to find the circumference, and that's going to be 44 centimeters. And also we can take that 7 and plug it into the equation of area. And if we do that, we get pi times 7 squared. 7 squared is 49, and so 49 times pi gives you 153.9 centimeters squared. So that's how to find area and circumference. Okay, so what I wanted to do after this is I wanted to show you about this notion of arc length and sector area. So what is this? So basically, arc length is the distance between 2 points on a curve in the circle. So for example, from here to here, you have sort of a fraction of the circumference. And in order to find that, you have to use this equation. This variable here, it's pronounced theta. It's a Greek letter. It's just usually used to denote angles, but it's pretty much just a variable, okay? So to find the arc length, it's going to be 2 pi r, which is the equation for the circumference, times theta over 360. Okay, that's the equation for arc length. And then sector area is just a fraction of the area of a circle. So it's basically like this piece of the pie right here. And in order to find the sector area, that's going to be pi r squared times theta over 360. So I'd highly recommend that you guys write this in your notes so you know how to find arc length and sector area. Okay, let's move on to our example 3. You're asked to calculate the arc length and the sector area, given that the radius of this circle is 4 and that this angle, theta, is 120 degrees. So please go ahead and pause this video and work on that, and then we're going to get it done in a few seconds here. Okay, everybody, welcome back. So let's calculate the arc length first. So remember, arc length is just going to be this distance right here, this proportion of the circumference, right? So in order to do that, we use our equation for arc length, which would be 2 pi r times theta over 360, all right, given that r is 4 and theta is 120. So before we plug this into our calculator, let's simplify it first. 2 times 4 gives you 8, and 120 over 360 reduces to 1/3, okay? So that's going to be 8 pi times 1/3, which reduces to 8 pi over 3, okay? So again, that's your exact answer, but let's go ahead and figure out the approximate answer, and that's going to be about 8.4 meters, okay? So that's going to be the arc length. Okay, so now let's move on to the sector area, which I've kind of highlighted right here in yellow. We're trying to figure out this distance right here. And in order to do that, we have to use this equation. So we have pi r squared times 120 over 360. So what we're going to do is simplify that first and then plug it into our calculator. So 4 squared gives you 16. Once again, this fraction reduces to 1/3. And so we have 16 pi times 1/3. And if we simplify it a little bit, we get 16 over 3 pi as our exact answer. And if we plug it into our calculator, you should get 16.8 meters squared. So once again, it's squared because it's a two-dimensional area. It's sector area, okay? So that's how to find arc length and sector area, okay? So make sure that you get those equations down and that you know how to use them. All right, everyone, so the last thing that we're going to go over is the equation of a circle, okay? So here I've drawn a circle, and generally we call the center of a circle, we give those variables h and k, h for the x-coordinate and k for the y-coordinate. R stands for radius, and this is just some point on the circle. So how are we going to get an equation for this circle? Here's how to do it. Basically, it's just a Pythagorean theorem. So this distance in green is going to be y minus k, and this distance in blue is going to be x minus h, okay? That's what that distance is going to be. So if we use the Pythagorean theorem, we get the equation of a circle, okay? So if you didn't understand this part, don't worry about it too much. You just pretty much have to know how to use the equation of a circle, and this is how to do it right here, okay? This is the equation of a circle. It's going to be x minus h squared plus y minus k squared is equal to r squared. So if I give you the equation of a circle, you should be able to graph it. So let's work on these two examples right here, example 4 and example 5. You're asked to graph the equations given that the equation of the circle looks like this. So let's begin with example 4 here. So with example 4, notice that this says x minus 2, and the equation of a circle has a minus right here, okay? So in order to figure out h, we actually don't have to change this 2. H is going to be positive 2. That sounds kind of counterintuitive, but that's only because the equation says minus right here, okay? So notice that this y right here is plus. So that means that k is actually going to be -1, right? This is the same thing as y minus -1, y plus 1. So the center of a circle is going to be at 2, -1, okay? So an easy way to get the center from the equation would just be to look at this and find the opposite of -2, which is positive 2. And then you look at this, what's the positive of 1? It's going to be -1. So that's where the center of the circle is, at 2, -1. Now to get the radius, notice that the radius, this part of the equation says r squared. So you take this number, whatever it is, and then you take the square root of it. So r is equal to the square root of 4, which is 2, right? And it makes sense because if you square 2, you end up getting 4. So that matches the equation. So once you have the center and the radius, you can go ahead and graph your circle. Here, I've graphed the center in green at 2, -1. Here, what I've done is I've used the radius, which is 2, to draw 4 points, one above, one below, one to the right, and one to the left of the center. And then we just draw a little circle around all the blue points, and then we're good to go. That is what the graph looks like of this equation. Okay, everyone, so let's go over the last example, example 5. So here the first thing we have to do is find the center first. So to find the center, remember it's the opposite of this number. So the opposite of 1 is going to be -1. And here, notice that there's no number. It's just y, right? So in this case, this is really just y minus 0, which gives you 0. So the center is going to be at -1, 0. Now, since this number is 9, that means that the radius, okay, has to be the square root of 9. In other words, what's squared will give you 9, and that number is 3, okay? So the radius, in this case, is going to be 3. So once we have the center and the radius, that's all we really need in order to graph this thing. So let's plot -1, 0 right here on the axis. So -1, 0 is the center of the circle. Then we use the radius, which is 3, to go 3 to the left, 3 to the right, 3 up, and 3 down to get our 4 points. And then we just connect them in order to make our circle. So that's how to graph a circle given the equation of a circle that looks like this.